Very good evening, everyone. Can you guys hear me? Let me know in the chat. Good evening, Arad. How you guys are doing? So, anyone solve the problems which we have done in the last class? Or further any other problem which you guys have solved it? I believe the last question which we have solved, those mostly were hard questions, and we have made all those hard questions very easy. And you can see that we were also seeing the applications of heap, the max heap, min heap. Very good evening, Hariharan. So I hope the last class was very interesting, and we are going to continue the same questions today as well. And we are going to see some interesting logic today as well with the heap. Yeah. Stuck at merge sort. Merge sort. Are you reading the starting part of data structure? Merge sort? Or you are talking about the problem which we have solved? Mm, that one, I think there was one problem, right? Where we got the matrix, 2D matrix, and we have to, we got that. Yeah, that one. Okay. Where you got stuck? Yeah, yeah. I think yes, some people have any doubt there. I believe, yeah, everyone has doubt why we are taking three values from the columns. Okay, interesting. Okay, sure, sure. I will answer it. Yeah, I think yes, I got one more message regarding the same query, that why we are taking three values from the column. Okay, so you got it, why we are taking three values from the column? What's the reason? What's the reason? Arad and anyone else can also tell. What's the reason why we are starting with the columns? Or why we are taking only starting three columns? A lot of people were asking to me, no, Hariran, they are not talking about that thing. Row number, index, and value, I think everyone has understood. They are asking why we have picked, the first loop. Let me share my screen. Let me share my screen quickly. The first loop which we ran, the first loop only we have inserted in heap the first column. Very good evening, Joseph. So I think Joseph has also the same doubt. So let me share the screen and let me open the merge sort one. You see this first loop where we are only inserting the first column. So people has questions why we are starting with first column. Yeah. So anyone wants to answer it? So see, it was very easy answer. So let me tell you why we are starting with that. That's right. The sorting is helping us. See, you guys are able to see my screen, right? Let me open the OneNote as well. In meanwhile, others are joining. We will just quickly cover this question. I think this was the median one which we were discussing. Or this might be some other question. That's fine. Yeah, this was the question, right? So just take this one again. So in the first array, we have 1, 3, 5, 7. And in the second array, we were having 2, 4, 6, 8. 2, 4, 6, 8. And then in the third array, we were having 0, 9, 10, 11. So first thing, guys, and what they were asking to us, they were asking us merge all these three arrays and then provide the final array. And that final array should also be sorted. That was the question. We have to merge all these three arrays. And after merging, these three arrays should also be sorted. Correct? But they have given one additional point, and that additional point was the arrays which they have provided us. Those arrays are sorted. Those arrays are sorted. You can see here 1 3 5 7 2 4 6 8 0 9 10 11. So it means if we are reading any of the rows, if we are reading the second row, this is our second row, right? This is our second row. This is our first row. If you are reading any of the row, you will be seeing that all the elements are sorted. All the elements are sorted. But you know what's the problem here? If we will start reading, start adding our elements in the heap, in any of the heap, main heap or max heap, if we will start adding our elements from the first row, like from the first one, we once first we added one, okay, and we are taking, you can consider min heap. So first element will be one, then we are adding three, three is five, then we are adding five, correct? So what we were doing in the min heap, the process which we are following, add add the element, and whenever we are adding the next element, whenever we are adding the next element, at that time we are also taking it out from the heap. We were also taking that element out. Yeah, we were doing the polling also. So you can see, once see first element we will get one, okay, we are good, we got the first element. But after that, we are not going to see from the first row. Even if we are in the first row, we are not sure this one is going to be smaller in all of the scenarios or not, because this one is going to be smaller in all the scenarios or not, we were not sure about it. So that's why what we did, because we know that all the arrays are sorted, all the arrays are sorted, so always their first element will be the smallest, correct? Their first element will always be smallest. So what we did, we have taken all the first element from the rows, and then we started out our traversing. First we taken all the elements from the first column, all the element in each row. We have taken first element, it means first column. So we have taken first column because we know that in each of the rows, that first column is going to be the smallest one. There will not be any maximum element after this column. You can see in this row, 0 is the smallest one. In this row, 2 is the smallest one. In this row, 1 is the smallest one. That's why we started from here. And after starting from here, whatever element is smallest, like 0 is here smallest, we'll take that one, move into that row, insert the next element from there. And that's how we are doing the traversing. That was the reason why we have taken the first column, because the first column is going to keep the minimum element from each row, and that's what you can see here, correct guys? That's why we have taken the first column, and then we are simply, whatever the minimum element we are getting, we are traversing. And then you have seen two problems there, right? When we are at the second row, like see, in starting we will be inserting three elements, 0 1 comma 2, and the 0 is the smallest one. So how we will get to know that from which row this 0 belongs, or what is the next index which we need to look for? So that's why we were passing two more informations, we are storing two more information. So first the value, then the row number, and then the next index. This is the next index, and this is our row number, and this is the exact value. So these two are just for helping us out. What is the row number and what is the next index? They are just helping us out there. Yes, next index of that row, obviously. Next index of that row. You can see. So it will tell us. So when we will store the 0 in our heap, we will be saving this information: 0 element, second row, and first the first index, because one is the next index. When we will be storing 4, you guys tell me, when we will be storing 4, what will be the information we are passing? You guys tell me, when we will be storing 4, what is the information we are passing here? You guys tell me. So 4 is at the so 4 as the first element, it would be 4. What would be the values here? What would be the values here? Here would be the next index. So next index is 0 1 2. So next index is 2. What is the row number? Row number is 1. because you can see 0, 1, 2. This is the row numbers. So this will be the output here. Let me see in the chat. Anyone's answer? Yes, you guys have written. Vishal has only written wrong. Otherwise, Arad has written earlier wrong. But yes. Oh, no problem, Vishal. Yeah, it happens. So that's what these three information we are passing. So I hope I answered all those two questions which you guys has. Any other questions in this question? The first question everyone was asking why we are taking the first column. So that's also answered. And this was the second thing. Any other question you guys have in this code also? Can't understand from code. Okay. See, so these two lines are already clear, right? We are going to create the min heap 93 to 96. Are we okay with these lines? Just let me do the thumbs up or anything. Everyone, yeah, we are good. Okay. Now this line, what about this line? So we have added the first columns from the array. You can see the row value is every time changing. You can see I will change 0. So first row, first column, then I will become first. So one row, first row, second column, I will become 2. So second row, first column. So every time we are just storing the information. And every time the value of I, the row number. So first time it will be 0th row, then first row, then second row. And we are every time sending the first index because after 0, after this index, every time for all the element, one index will come. So I hope these lines also you guys have understood. 98 to 100. Are we good with the 98 to 100? Everyone? Yeah. Okay. Let's move further. Let's move further. Now in our now in our min heap, we have three elements, right? Now we'll start doing the polling, and try to navigate for the next maximum. Correct? So that's what we are doing. So see, so we started our loop. We are going to traverse all the elements. We are running this loop for all the elements which are exist in our matrix. So that's what we did. Array dot length. This will provide us the total number of rows. This will provide us total number of rows. And array 0 dot length, it will provide us the column. You can see that with the code also. If you will, this is the big array, the parent array. So if you will write the array dot length, it will provide you 3, which will give us the row number. And if you will do array 0 dot length, it will provide you the column numbers. So that's what is happening here. So we have multiplied that many times we are running the loop. Correct. Then what we are doing, we are first taking the peak element, whatever the peak element in the min heap. So definitely it will be 0, right? In our case, if we are inserting 0, 1, 2, so definitely 0 would be the peak element. I hope understood, right, everyone? Till now, you can see we are doing the line number 105. Understood? Can't we do array dot length in 104 line in 98? In 98. Array dot length. No, we can't. Array dot length will run your loop only 3 times. Array dot length will run your loop 3 times, but you have to traverse all the elements in that. You see, array dot length is 3, but you have to traverse all the elements, right? 3, 5, 7, 4, 6, 8, 9, 10, 11. How will you get the total elements inside it? You will get it when you will run, when you will have, you can see, what is the array length here? 3. What is the array 0 length is 4. So you will get 12. So you can see total number of elements are also 12. So you are traversing all the elements. Understood? You need to traverse both rows and columns. Okay, so yeah, what we did? So we have deleted that element from the peak, like a heap, min heap. You know these steps, right? We have taken the peak element, then we inserted it. Inserted our root 0. You know that at any of the element, we have 3 entries, right? You can see they here. We have 3 entries. This is a 0 index, this is a first index, this is second index. So once we got 0, this is root right now. So we can see we will store this as our answer. So result is an answer. So we will push 0. So that's what we did. We are pushing our answer in result. Then we are checking for the next element. Then we are checking for the next element. Whatever we have removed from the heap, let's go for the next element. So that's what we are doing here in the line number 112. You can see array 1 root 2. It means it is telling us Go for, see, root 1. What is root 1? So it will looking like this. Array. What is root 1? 0, which is 2 here, and 1. Correct? This is happening like this. Array root 1, root 2. So what is this? Array of 2 of 1, which will give you 9. Which will give you 9. So that's what. First you will insert 9. Then you have to insert the row number, which will be same thing, 2. And then increase the index. So it would be root 2 plus 1. So that's what happens. See, you have increased the index, you have taken the row number, and then you have taken the value, and you are passing all those information in again an array. How you are storing these three things. So that's what. I hope now 112 line number 112 is clear. Where we are just adding the next element, similar like the line number 99. You can see the line number 99 and line number 112 is not at all different. Here we are just simply passing the I comma 0. Here we need to take it from the root, those indexes. So we have taken those indexes, then we are passing them. And we are increasing the next index. I hope line number 112 is clear to everyone. 1110 and 1112 again. No, 1110 I have not talked about. 112. First tell me 112 you guys have understood or not. Line number 112 is easy. So which part exactly you're not able to understand, Arad? See, did you see the similarity between the line number 112 and line number 99? Is there any difference in the line number 99 and line number 112? What difference you see? And you know this root 1 and you know the root 2 root you know these values, right? These values are coming from here. These values are coming from these places. Root root 0 would be, let me write it also for you. Root 0 would be 0, right? And root 1 would be 2, and root 2 would be 1. You know now these three values, right? From the root. So that's what they are. You are putting those values here: root 1, root 2, root 1, and root 2 plus 1, and putting all of them in array. So you can see that's what similar thing you are doing here in the line number 99 also. So line number 99 and 112 is totally same. So we are polling 2. So polling already happened, right? In the line number 116, 106, already done the polling. Then only we got the root value, peak value from the mini. Now you guys got it? Arad, you got it? The line number 112? Yeah. So now let's talk about the line number 1110. Why we have written this line number 1110? So see, the reason for that is that once you reach to this index, you do not want to insert the next, because you know in the JavaScript array have null, right? They are by default null or undefined. Yeah, undefined. So they can insert the undefined also in our min heap. So that's why we need to stop it there. We do not need to insert anything there. So that's why we are checking wherever root 2. How we are getting the indexes? We are getting the index with the root 2 always. So right. So we are checking that root 2 should be less than root 2 should be less than root 1 dot length. Root 1 dot length. Or root 1 would be array. What is root 1? Root 1 is telling the row number. So row number array 2 dot length. So the index should be less than the array dot root dot length. So that's what happening in the line number 110. In the line 110, you can see the root 2 is your current index. An array of root 1 is telling you that particular row length. So that particular index should be less than to that particular row length. Then only go and fetch the next value and then insert it. Otherwise, these values root 2 plus 1 and root 2, you will not able to get it because you do not have anything there. Already you have already traversed everything. That's why it's just a safe condition which we have written here. That's for we should not be reading any of the information which does not exist. That's why we did. the line number 1110. Yeah, root 1 is C. Yes, root 1 is root number. See, just see this value, right? From the day one, I am trying to tell you, just see this root. This root is going to help us, right? The information we are going to store, those things is only going to help us. This is the value part, this is the row part, this is the index. Root 0, root 1, root 2. Now everyone is clear about this question? Any doubt? 98 iterates only 3 times, not 12. 98, line number 98. Yes, we're only iterating the first column, right, Joseph? We're only iterating the first column. And in the first column, only 3 elements. We are only iterating the first column first time, right? Then we are going into then we are first pulling it out. You can see here, we are not pulling it out anything. We are just adding everything because we do not know. In the first column, we do not know which is the minimum element. That's why we inserted all these first column fully in our heap. And then we started pulling it out. You can see that. So first row, first column, we are simply adding all the elements in our heap. Then we started pulling it out. And then when we started pulling it out, also we started inserting the next one. Why we taking root 2? Why not root 2 dot len? Arad. Root 2, what is that? Root 2 is index. How can you take the index length? This is the index. This is telling you the index. 4, 3, 2, 1. This is telling the index. Root 1 is the array number, right? Root 1 is the array number. So how can index tell you the length? See, guys, I think you guys are confused. Why? Like you guys should see this thing, right? What we are storing in root. That's the important thing, which will help all of your doubts. In the root, we are storing, see, I've clearly mentioned, we're storing value, row number, and next index. So how can next index can tell us the array length? It can only tell, we can only get to know about the row with the second one, which is this one, the first index. Right, guys? Yeah. See, that's why I'm trying to tell you guys, this one is important here. Root 0, 2, 1. This is going to tell you everything. When index goes to 5, and it also sees whether it exceeds the row number length and it stops. Yes. When the index goes to 5, in this case it will go to 4 and then it will stop. Because see, our condition is here that root 2, if it become 4 and array root dot length is also become 4, this will not go inside yet because we have not put the equal sign. So when the index will become 4, it will stop there. And that should be happen. Yeah, root 2 is telling the next index. Okay. It really got mixed up in mind. Yeah, we need to see a little bit, a little bit broader. Array dot length is, Joseph still has to see something here. Okay, Joseph. So, what is happening? Yeah. So Joseph, this is our array, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, Joseph, you tell me what is the array dot length? This is array. What is the array dot length? Joseph, tell me what is the array dot length here? Yes, that question is hard. Rows. No, tell me array dot length here. That's the array, right? How many elements this array has? I'm talking about the array. You're saying 12. That's wrong because you see that I'm telling you this is our array and it has. Now, you guys tell me now. Joseph, tell me now. What is the length of this array? What is the length of this array? 3. That's right. Now this element has been replace with the array. This is array. Will that change the length of array? Will that change the length of array? Joseph, will that change the length of array? No. So yes, still the array length will be 3. But if you want to count all the elements here, what you will do, you will go to the array 0 index, array 0 index, and then take the length. So what is array 0? What is array 0? Array 0 is this array. Array 0 has another array. What is the length of this array? Which is 4. So now you are multiplying 3 multiplying by 4. Now you will get the 12 elements here. And that's what called as row multiply by column. So this array dot length will give you row, array 0 dot length will give you the column. Got it now? No problem. So now we are good with this question, guys. Yes, this question is not tough. You just need to practice. See, just like see, I always keep my diary near to me and one pen. Always I practice all the questions through these diaries and through pen. It clears the mind actually. So I will suggest to everyone do the same. Next question is also interesting actually, and that's also tough. And let's jump into the next question. I hope now most of the people has joined. So let's jump into the next question. No, nothing like that. Nothing like that. Doesn't need any sixth sense or anything like that. It just needs little bit patience and you know, little bit patience only. With patience, everything comes. You just need to patience and focus. You will automatically get it. Okay. Okay. So now let's jump into the next question, guys. That's very interesting question. And you know, that's also one real-time application of heap. Real-time application of heap in your OS that happens, and heaps helps you there. Let me show you the question now. First, let me show you this in slide, because in the slides they have not given anything actually. But yeah, but let's look into the lead code. By the way, it's not hard. So anyone is looking for hard, so it's not hard, but it's very interesting question. So let me tell you, let me read this question to you. Given in character array, this is the character array, and that character arrays are representing representing the task a CPU needs to do. So these are some of the tasks which CPU needs to do, where each letter represent a different task. Okay, you can see these are task A, these are task B, means different tasks. Okay. Tasks could be done in any order. So these tasks could be done in any order. Okay. Each task is done in 1 unit of time. So they are saying once you will put this task in a CPU, they have to take 1 unit time. Okay, and they will be finished. So like you can see, A is coming 3 times, so it needs 3 unit of time. B is coming 3 times, it needs 3 unit of time. Okay. Now they're saying for each unit of time, the CPU could complete either one task or just be idle. So see, they're saying for each unit of time, CPU could complete the task or it could be ideal. So like if you're not scheduling or if you're not putting your task in CPU, at that time CPU will be ideal. CPU would be idle at that time. Okay, that's what they are suggesting you, that's what they are telling you about the CPU. Okay, now let's read a little bit more about it. Now they're saying here, however, there is non-negative integer n that represents the cooldown period between the same task, the same letter in the array. Okay, that is, there must be at least n unit of time between any two same tasks. From here, now this question has taken some twist. From here, now this question has taken some twist. I will explain you what they're saying. Then they're saying return the least number of units of time that a CPU will take to finish all the given tasks. Okay, so now they're asking, tell me how much least amount of time a CPU needs after applying all these previous conditions. How much time CPU needs to finish all the tasks? Okay, that was the question. And in the slides, like in the slides, they have same question. This question has different meaning, but that's the same. Let me show you. Let me tell you the slides question also. So they have taken the question there as an office number. Like there is one office, there are n number of employees, and they all have to assign the same person a task. Similar thing. So guys, I am telling you with this example, the task scheduler one, okay, which is available in lead code, not with the slide one. But yes, both are same, both questions are same. At the end I will, like, once we will solve the explanation with this one, then I will read the slide question also. You guys will quickly understand that they are same. Okay, so now let's jump into to understand this question first. Okay, so now let's take the array there. So So this is the task array. I'm just writing like this: A, A, B, B, and B. Correct, guys? This is the 6 task which has been given to us. Then they have provided one value to us, which is they are saying as a cool down period. N is equal to 2. N is equal to 2. Correct? And the third thing they are saying, guys, you can read here, that is, there must be at least an unit of time between any two same tasks. Bus, this is the line which is going to create some problem. This is the line, guys, which is going to create some problem. What is the meaning of this line? This line is saying, if you have assigned one task, like if I'm taking A, right? So if I'm taking, this is my CPU, yeah. So this is the, like, t is equal to 1 right now, the first unit of time, or no need to take time. So just understand, I have taken my task A here. Okay, now they are saying, guys, I cannot take A after 2 unit, I cannot take A between any 2 units. I can only take A after this, after 2 units of time. I can only take A here. That's what they are saying, guys. The cool down period is means we can only take, there must be at least an unit of time between any two same tasks. So same task, you can see we can only assign these same tasks again to the CPU after n unit of times. After n unit of time, we can assign another task here. It's not like that we can't assign another task, but they're saying same task cannot be assigned, can only same task can only be assigned after the cooldown period. And after, right now in our question, cooldown period is 2. So you can see I left 2 unit of time and then I assigned A again. In meanwhile, I can assign B here. But now you can see, guys, I can't assign anything in this time. I can't assign anything in this time, because this is the first for 1 unit time. This is second. This is third. This is fourth. You can see B also needs two units of. I can only assign B here. I can only assign B here. I can assign B here, and then again it will be same. After A, 2 units of time. After B, 2 units of time. So I can assign A here. Now you can see all of the A task has been completed. All of the A task has been completed. Still B task is there. So I can assign the B task here. So you can see 5, 6, 7, 8. So total time has been 8. If they are asking about the 8, so this will be the unit time. And the guys, this is the ideal scenarios. Here our CPU is ideal. It's not doing anything. That's the question, guys. I hope some people has got it, but let's see. So you can see output as 8, and you can see the same A, B, ideal, A, B, idle, and A, B. Correct, guys? Cooldown for every element is same. Yes, cooldown period for every element is same. It's going to take that much unit time for again coming into the CPU. Okay, yeah, I will definitely explain it again. Can you explain why it is 8 again? Okay, let me answer that question to Ekta. I think she has understood most of the things. Let me explain just the eight part. So see, Ekta, the part of 8 is that much time we are taking in the CPU. You can see that much time we have waited till all of our task has been completed. You can see B was coming 3 times. So we have assigned B in our CPU 3 times. And then you can see we have assigned A 3 times. You can see A. So that must the minimum time which our CPU taken to complete all of the tasks. That's why our answer is 8 here. Understood, Ekta? Yeah. Okay, now let's draw it again, guys. Let's do it again. No problem. Let's do it again. Let's understand again. So first thing you have to understand, which is written, which is mentioned there, that two same tasks can enter in CPU after a cool down period. After a cool down period. That's the important condition. Okay, this is the condition which you need to take care in your mind. And let's do it again. Okay, let's do it again. Let's understand the question. No problem, guys. I know this is a little bit complicated, but that not that much complicated. Okay, but let's try to understand again. Okay, so I am saying two same tasks can enter in CPU only after a cooldown period. Here only I can add only after a cooldown period. And what is our cooldown period? Which is 2 units. So let's start assigning our tasks to UPU. Any task I can take. I can take A as well, B as well, because there's one more thing you need to assign. You need to understand. But let's fine. We will talk about that later. Which should we pick? Right now, anything we can pick. We can pick A as well B. No, there is nothing like that. So we will first pick A. So I have assigned this A to my CPU. And because I told you, every task is going to take 1 unit time to complete. It's mentioned there. Every task is going to take, you can see, each task is done in 1 unit of time. Correct? So every task is going to take 1 unit. So this task is assigned in CPU. It is going to take 1 unit of time. So I'm writing here time of this one. Now my condition is once this one is completed, can I assign the A again? Can I assign the A again? That's the condition. I cannot assign the same task again. I can only assign the same task after a cooldown period, and which is 2. So I can only assign A after a 2 unit of time. I can assign A at this place. I can assign the A at this place. Again, still A is pending there. So I can only assign this A after a cooldown period A here. That's what you need to understand. Same task can only be assigned after a cooldown period. Now, okay, if same task cannot assign, can I assign different task in meantime? Because our CPU is ideal this time. CPU is not doing anything. So yes, we can assign another task. So if we'll take B, so we'll take the B here. This is the second unit of time. But again, same condition for B. Can we put another B here? No, we can't put here because again, 2 unit of time should be completed, and 2 unit of time will for B will be completed after this. So we can assign our element, our task B here only. Then again, this B and this, then we can assign our B this place. So how much unit of time we have wasted after completing in all of, or not wasted, how much time we have spent here while completing our task. You can see this unit, this unit, this unit, this unit, this unit, this unit. So total is 8. And here in these places, you can see our CPU was idle. That's what the question is saying, guys. I hope this time it makes little bit different than the earlier. Yes, if we have a C, we can place on those places. Totally right, Arat. But yeah, same condition for C also. The next C you can only assign after two unit of time. Everyone understood? And n is equal to 2. Yeah, that will be provided in question. Arat. N key, the value of n will be provided in question. It's clear now? Got it completely? Anyone has any doubt? Suraj? Okay. Suraj has joined the call today or not? I just got his name. Mine was mentioned above. Your question, Vishal, okay? Vishal's questions. Why is there ideal period between A, comma B and A, comma B? So, still you didn't understand, Vishal? The reason for why the CPU is ideal? Because, now you understood. Okay, good. So because there is cool down period, and at that cool down period, we can't assign A as well, not can't assign the B. So that's why the CPU is ideal at that time. Because of our condition. Our condition is saying two tasks cannot be assigned. But if we go alternatively like A, B, A, B, A, B, but we can't, right? We can't go like this. A, B, after A, so lesser type of task, there will be more idle scenarios. Yes, more idle scenarios. There's no need of. See, Vishal, if you will go like A, B, A, B, are you fulfilling the condition of cooldown period? The condition is two same tasks can only be assigned after 2 units of time. And you are going like this. A, B, A, B. You can see the ideal time between two tasks is 1 unit time only. 1 unit time. You can't go like this, right? You need to spend 1 more minute here, unit here. That's what we are spending here. The 1 more unit. In that unit, neither we can assign B or nor we can assign A. That's why that is going into the ideal state. Got it, Vishal? That's why the condition is important here. That you missed. That's the important part, Vishal. That's fine. Yeah. That was the important part actually. That condition is only creating a problem. Otherwise, if that condition is not there, we can simply assign, as you mentioned, it will take 6 units of time then. If that condition is not there, guys, all three tasks, anytime, like it will only take minimum 6 units of time, right? It will minimum take 6 units time, but that condition is creating some problem. Okay, so now we got it. This thing, right? Everyone, anyone has any doubt? Vishal has understood. And Ekta has also understood. Everyone understood, okay? Yeah. So now let's see. Let's do some. No, sir. Suraj has not understood. Okay. Oh, you answered about the zero. You okay? You are answering about no doubt. Okay. Oh, okay. Thank you, Suraj. Yeah. If zero, simply written array dot length. If zero, simply written array dot length. Mm, if n is equal to 0. Okay. If n is equal to, yes, yes. I got it. Yes, yes, yes. If n is equal to 0, yes, he has given correct answer. If n is equal to 0, we can assign anyone. Yes, yes, that's right. I think it is given in the example also. You see, in the example, they have given the n is equal to 0. You can see the answer is 6 there. That's totally right, Parag. Yes, he has done the good observation, guys. Yes. Clap for that. That's a good observation. If n is equal to 0, then it would be 6 directly output as 6. Correct. So now let's do some more observations, guys. Let's do some more observations. Okay. Let's do this question is actually interesting. So let's do some more observation. So now let's think about if we have given uh, task A 4 times and task B 3 times, task C 2 times, and task D 1 time. Okay. And the value of n is 3. Let's consider this thing. The value of n is 3 will work. Yeah, let's take the value of n is equal to 3. Correct. So guys, this is now but you are able to understand this question, right? First tell me, you guys are able to understand this question now? We have given task A 4 times, which has to be go into the CPU 4 times, and task B 3 times. It means it has to go into the CPU 3 times. Now we have given task C as 2 times. It has to enter into CPU 2 times. Same for D. And our cooldown period is 3. It means a task who has entered into the CPU can only be entered into the CPU. It can only be entered again into the CPU after a 3 unit of time. You guys have understood this? So now let's think about one observation here. Which item to pick first here? Which item to pick first here? Because they are not telling like based on arrival time or based on anything you need to take. They are not telling anything in the question. But we need to decide which one to take first. Or 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 the question could be uh, like the which one should be not leave for last, like the task, which one we should not leave for last. Yeah, that would be the question. Yeah, that would be the question. The which task from here we should not leave for the last. I think you need little bit thinking here, little bit thinking. Just think little bit about which task from here we should not leave for the last, because based on that we are going to decide. See why we are telling about this question, because based on that we are going to decide we have to take min heap or max heap. Based on that only we are going to decide we are going to take min heap or max heap. Okay, so Ekta is saying A, then we'll have more ideal scenarios. See guys, I think yes, Ekta is correct here. Let's see, someone else are also answering. We can keep remaining in ideal. We should not leave A for last. Yes, that's totally right. We should not leave A for last, because you know that, because A needs little bit more. See, the A has to enter extra compared to others. The task A has to enter in CPU compare more than compared to other tasks. It means if we will leave A for the last, definitely after assigning A, it has to wait for 3 units of time, and then again next A will be coming. Like if you remember, after, like if we are taking B and then again B, then again C, and if we have finished everything 0 0 0 and only A as a 2, at the end A is 2 and everything is 0, you will see A, after assigning task A, we have to wait for 3 units of time, then only we can assign next A. Correct? So this will be wasted here. This is the wasting, like this is the wasted of time we are doing here. If we start, like when we are start assigning the task, if we do the smartly, whatever the maximum number is here, we will be start picking that number, we will start choosing that number as our first task again, right? After a cooldown period, we should be smartly put our task. So whatever task have the more frequencies, I think we should first finish that task. We should first finish that task. Otherwise, at the end, that task is going to be in the, that otherwise that task is going to take more, like whole cooldown period. I'm not saying this is going to help in every way, but yes, this will definitely reduce somewhere some time. So that's why, guys, we are going to take the max heap here. That's why we are going to take the max heap here. Max will or max heap will always give the element which where the frequency is larger, where the frequency is larger. That's why we are going to take the max heap here. Now, why we are not taking the min heap? We also know the reason. Understood, guys? Yes, the task which have more frequency should go first. Yes, everyone understood. Now let's think about little. But I think, yeah, these were the solutions only. This was the two observation we need to do. Now we can talk about the solution. Okay. So we have taken the max heap, and you know that we have also taken the frequencies. Correct. So for calculating the frequency, what we will use? First, tell me, for calculating the frequency, what we will use? For calculating a frequency, what will you use? Oh, why? Oh, okay. Okay. Ara, Joseph, Vishal has only mentioned about object. Why you guys didn't mention about the map? See, Ekta and everyone is given the answer. Yes, yes, yes. You should always tell map and object. Yes, we can take any of these things to calculate the frequency. So let me show you this part in the code quickly, because that's the first step we are going to do that. Okay. So let me show you that part first in the code. You can see the first part. They are taking employee as a task here, guys. See, in the in here they are taking employee as a task. But yeah, just understand this employee and task is similar. So that's what in the first step we are just calculating the frequency and storing in our employee counter. Okay, this is the first step. And then the next step also you have understood this thing. We are going to take our max heap here. We are going to take our max heap. So this line, just tell me from the line number 102 till line number 150, till line number 114. Just ignore the remaining one. Till line number 14. Oh, see, you guys also understood this line also, right? We are just adding all those frequency in our, we'll see after this later. But yeah, we are adding all those frequencies with key in our heap. So I think yeah, till line number 118 we are good, right? Anyone has any doubt? Just read about it. Your employee counter is task here. You are passing M rather than passing task, you are passing employee here. So this is the frequency part. This is the heap creation part, max heap. And here we are keeping the key as our employee and value as a employee frequency. That's why you can see in the comparator we are also using the 1 index, not 0 index, because based on the frequency we are going to do the comparison. So guys, anyone has any doubt here? Line number 102 to 118. Are we good here? Let me come back to, yeah. Yes, same as sort by frequency. Totally right. Totally right, Ekdam. That question we did similar like that. Joseph, Arad, Ariaran, guys have any doubt here in the code? Can we move further from here? 112. Okay, 112. Suraj is 112. Yeah. So Suraj, this is the line A1 greater than V1. So greater than, it means it is telling us it's going to be max heap. And why 1? Because we are storing two things in our heap. One is the key and second one is the frequency. It means we are storing these two things, A, comma 4, like this, A, comma 4. B, comma 3, C, comma 2, D, comma 1. And we are going to do our comparison based on this index. This 0, 1, 0, 1. So that's why I did A1 greater than V1. Understood? Suraj, line number 112. Why A1 is there? Yeah? Everyone good? We can move into the next part now. Okay, okay. So now let's move into the next part. Okay, guys. So now let's start assigning. Okay, so guys, we are definitely clear that till our till we have any task, till we have any task in our heap, we need to run 3 times, right? We need to run 3 times. If we have any task here, like if we have A, at the end, just consider if we have A. So it means if we have A, so we have to run this loop 3 times now. Correct? Because this is coming at the end. And after this three our heap will be 0 and we will not go further. So it means guys, what I'm trying to say here, after, if we have any element in the heap, we need to run our loop 4 times, like n plus 1 for that element. If we have any or one element in heap, we need to run 4 times. Did you guys understood this thing or not? Because at the end, just consider if we have completed 3, 2, 1, all become 0, 0, 0. At the end, only 4 become 1. So we need to put it into the, we have to put this 1 into the stack, into our CPU. So, and we have to run our loop this 4 times. We have to run our loop 4 times. So that's why, guys, what we are going to do, we are going to start our loop from the starting. From the starting, see, let me tell you what I'm going to do here. 4, 3, 2, 1. So first we'll take this element. A is equal to 4. We'll take this one. Correct? Second thing, what we'll do, we'll reduce his frequency. So his frequency will become 3. Correct? This frequency has become 3. And now, because the frequency of this element has not become 0, we will again insert back this element in our heap, right? Because we need to pick it again. This task still has 3 frequency. So we have to pick this task again. Am I right, guys? We need to pick this task again. So what we'll do, so the first step would be First step would be take the max item out of heap. This is the first step. Second step, reduce the frequency. See guys, we can't directly, after reducing the frequency, we can't directly add it into here. We can't directly add it into here because 3 will be inserted. 3 will be inserted. And again 3 will be coming out. But you know that we have to wait for 3, we have to wait for we have to wait for these 3 cycle to complete. We have to wait for, see guys, for this cycle I'm going to run a loop. That loop will be I is equal to 0 to 3. So it will be 0, it will be 1, it will be 2, it will be 3. For this element 3 time loop will be running. So guys, what I'm going to do, what I'm saying, after reducing the frequency, I can't directly insert this A, because if I will direct insert this A in the next loop, again this A will come out of it. Again this A will come out of it. That's why we are going to take just one more array, which is going to called result back or anything, just backup array. We can say it as a backup array. It's a backup array. And in this array, I'm going to keep my A comma 3, the updated values, A comma 3. Then in this loop, now A has been assigned here. Just consider, like visually, you just understand this A has been assigned here. Now again, same step. Take the max item out of the heap. So now max is B. Guys, are you able to understand? Now why B is max? Because we have taken already A out of the heap. Correct? With the first step, we have already taken A out of the heap and we have not inserted it back. We have not inserted it back into the heap. We have inserted it into the backup array. We have inserted it into the backup array. We have not inserted it back into the heap. So that's why the next element would be B. So now we'll take the B here. Again, we'll do the same thing. We'll reduce the frequency to 2 and insert it into the backup array, B comma 2. Now these are the 2 elements left only. We'll do again the next max element, which is C. Again do the same, reduce the frequency, C comma 1. Again still one thing is left here. Again take the last one from the heap, D, and D comma 0. So now D comma 0 is there. We will not insert it because we do not want this one. Because once the D becomes 0, any of the tasks become 0, will not insert it into the backup array. Why we are not inserting? Because we are inserting those tasks here which we need again back into the heap. That's why we have not inserted D, because D has already become 0. So we do not require D. Correct? So that's why we did this thing. So now let's move further. Next loop of I will again run. So before that, just add all these 3 elements into the heap. Before that, add all these 3 elements again into the heap. So it will look like this. Because max heap, A is still at 3, B is still at 2, and C is 1. So now this will look like this. Again, the loop will run for 4 times. Same step. Take the max item out of heap. Now we'll again take the A. Again, a second time backup array. Empty backup array. Say again will come. Again, A comma 2. Just see the guys flow. A comma 2. Again, take the max item out of it, which is B comma 2. So B comma 1. We are reducing the frequency as well. Again, C. Because C becomes 0, will not add into the backup array. And now this time, this will be idle. This will be idle scenario. Getting it, guys? Anywhere you guys stuck? Anywhere you are stuck here? We didn't put the back in the A is equal to 3, B is equal to 3, both come. Why we need backup? I didn't get that. See, Arad, sorry for background noise, guys. For creating a backup array, see, when we have inserted this, when we have pulled this out A outside of our heap, and we have to run 3 times, right? We have to wait. We can't insert this A after reducing the frequency. We can't directly insert it. We have to wait for this loop to complete, this cooldown period to complete for that element. That's why we are storing those tasks which have frequency greater than 0 in our backup array. And once this loop this cooldown period will complete, we'll again insert them into the heap. That's why we are using our backup array. Understood, Arad? Yes, we understood the backup thing. Okay, let's see another question. A is equal to 3, B is equal to 3, both come. Okay, so I think Suraj got the answer. So we didn't put back in the heap Suraj since B has max frequency which is 3. Okay, backup array would recreate heap. Yes, that's right, Vishal. Backup array will again create the heap. Again create the heap. If root 1 greater than 0, we insert into the backup array. Yes, yes, Ekta, that's right. If root 1, it means the first element of that task is greater than 0. Yes, we are inserting into the backup array. Totally right. Where root is equal to heap dot peak. Yes, yes, that's right. We already used 1A, Suraj. No, as of now. Okay, so everyone has understood, right? Everyone can like are able to get it right. Whatever we're doing there. Okay, let's move further then. Let's complete this question. So, guys, you understood the idle part also. Why we got the idle here? Vishal, this time you got it. Why we got the idle here? Yeah. Okay. So now still we have two elements in our backup array. So let's again create the heap out of it. So now the next heap will look like this. A2, B1. Again do the 4-time cooling down period for A. So A have taken, again go back to our backup array. A comma 1. Correct? And then take the B, but B becomes 0. B is becoming 0. So we will not insert B here. This all will be idle. Ideal. Guys, correct? This two will be idle. And next, again, this is the final backup array. So now at the end, we'll only see a comma 1. And that's what the scenario I was already telling you. This all idle will come here. This again all will come here. And why we are going into this idle? Why we are not stopping? Because we do not know that, right? Because we do not know that there is any other element in the backup array or not. So I think the final answer should be here. If they are asking about the time, so the final answer should be here. How much time CPU has taken total? So 0, 1, 2, 3, 4 unit, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 unit of time it is taking here. Let's see if we have anything for the last condition. I think yes. What we can check there for the last condition when the cooldown period is happening, in that scenario we can check. After the second index, we can check like if there is anything we have inserted. Let's see. Yes, yes, that's what I'm thinking. We can check that backup array. Might be, let me check. It might be we are checking that thing. Let me check in the code, guys. Might be checking. Let me see. Hmm. So yeah, we are checking it, guys. Yeah. See, we are checking it. So we will not go there. Yeah, you guys are right. We are checking this thing. So it will only be stop here. I was wrong. It will stop here. It will stop here. That's right. For B, comma C, are we checking cooling period? For B, comma C, are we checking cooling period? Oh yes, it's yeah, we are checking that, right? See, Joseph, where is the B? Here. We have already taken it out from the heap. We have already taken it out from the heap. So for the next two instances, can't use B here. Can't use B here. Right? We already use check whatever element we have taken it out, we can't use it again for the same cooling period. And in the next cooling period, we are going to wait for that. So let me now let's look into the code, guys, also. So this is our final result where so in this question We are not going to count. We are not going to count. We are going to insert our task. How many time we are inserting our task and idle. So that part we are going to insert it here. So see, you can see this is our final array. This will be our output. Okay. Now you can see I'm running my while loop till till any element we have in the heap. Till any element we have in the heap. This is our backup array. This is our backup array. And then you can see we are running 0 to x. It means that cooling period. Our x is here, cooling period. So it will run 0 to 3. So you can see 0, 1, 2, 3. So that's why this is the condition. And inside this condition, taking out the peak, inserting into the result, polling it out, reducing the frequency here. If the frequency is greater than 0, as Ekta told that, we are pushing that element to the backup array. If if in the same if in the same cycle, if in the same cycle, uh, wait, if in the same cycle, yeah, wait 1 minute. Yeah, if in the same cycle, if we do not have anything in the in our queue, in our sorry in our heap, we are pushing idle at those positions. You can see that, right? Like this scenario, we are pushing idle. And then at the end, the last condition which you guys told, right? When our heap also becomes 0 and the backup array length is also 0, we are breaking it there directly. And then once this for loop is completing, I am just going into my add backup array and adding everything back into the heap. And at the end, I am returning my result. Yeah, this was the code which I explained to you. So just spend some time with this code, guys. I will give you some minutes. You guys just see this code, and then I will answer your questions if you guys have any queries. Taking it out, pushing into the result array, polling it, reducing the frequency, checking if frequency is greater than 0, add into the backup array. if if in the same cooldown period, if we do not have in the heap, if we deleted everything out of the heap, so simply push idle, and then again check. After pushing the idle, then check if the priority queue dot size is equal to 0 and add back dot backup length is equal to 0. Break it. That for loop will be break. You can see this if condition is inside the for loop. So this will be breaking here. And then at the end, adding back all the elements in our priority queue. And then again, same backup array will become empty. And again, same thing will happen. Okay, now I'm coming back to your questions. Okay, so line number 132. Line number 132. Yeah, so we are just pushing all the elements into our backup array. Okay, Ekta here. Sir, why are we adding back to heap? So because Hariharan, after taking 3 pole, our heap is empty here. Heap does not have anything. We need to add these element again into the heap. So we can take them again into our CPU. So that's why we are adding them back into the heap. Okay. Okay, sir, we should do push root 0, right? Push root 0. Wait. No, no, no. We have to push both things, right? The element and the frequency. And why are we adding back to heap? Understood what why we are adding back to heap. Ekta, what it yes, we got it right. This part, the Hariharan was also asking the same. We have to add this element again into the heap to get the maximum out of them. There are two elements, A and B. Which ones to choose? We'll add them back into the heap and get the maximum one. It's like updated heap. Yeah, it's like updated heap. Yeah, correct. We are updating a heap. Yeah, sure, sure. Yeah, let's see the code. Guys, spend some time. Are we good here now? Any other queries, guys? Joseph, anyone else? Are we good here, guys? Do you want me to show you so again, or are we good here? If you remember the steps which we did, if you remember the steps, just repeat those steps. Take out the element from the heap, reduce the frequency, check if the frequency is not become zero, push it back, right? Do the same step again and again. If we do not have anything in the heap, push idle there. And then at the end, if we do not have anything in the heap, do not have anything in the backup array as well, break the loop. And at the end, just add back whatever we have in the backup array back to our heap. Got it? Yeah. Everyone feeling good, confident after understanding the logic and code. Logic, you just need to understand the logic part. Code was very easy. Definitely, definitely. Practice is definitely required. Yeah. Can we move into the next question, guys? Meanwhile, anyone has any doubt? Let me know right now. Hariharan, Suraj, Joseph says yes. Arad we says yes. No. Okay. Take it. Okay. Let's move into the next question, guys. Can you share the notes on GitHub? Okay. If you're talking about this notes, okay. Sure. I will take the screenshot and add it into the LinkedIn. Okay. Okay. Welcome. Let's see the next question, guys. Rearrange string. Okay. So next question is rearrange string. Let me see if we have a similar question in our lead code. Oh yeah, we have it. Okay, so problems M has become 2 here. Okay, now let's see. Okay, so what is this question saying, guys? We have an string S which has some characters. Okay, so they are saying two adjacent character are not the same. We need to see, we have given this string AAB, correct? So we have to arrange this string in a way so two adjacent characters should not be same. So like this AAB. So if we say this example like this AAB, we have to rearrange this string in somehow that two adjacent characters should not be same. So like A, B, A. You can see two adjacent character A comma B, they are not same. B comma A, they are not same. But BAA, this is not correct. Not correct. Because you can see two adjacent characters are same. Same, this is also not correct. AAB, this is also not possible. But they are saying, is there any possibilities that we can convert or rearrange this whole string into this way, ABA? Let's just take another example. Like if we have 3A here, is it possible now? Is it possible here? No, right? So see, ABA, always one A will be extra here. Wherever you will put it, it will always break your condition. And your condition is two adjacent character should not be same. So that's why for this question, answer would be false. For this question's answer is true, because there is one possibilities if we keep our characters in this way, there is possibilities that it will fulfill the condition. Let me see what they are asking. So they are asking you have to return the or rearrange a string. If no, if not possible, just return the empty string. You can see at the end one we are returning the empty string, and if there is any possibilities, just return the final string. Understood the question? Yeah. Is it somewhat similar to the question we did just now? Little bit similar, little bit, because again, I think you can see there is some relation with frequency. Again, there is some relation with frequency. We have to reduce the frequency again and check with the previous. So yes, some similarities is there. Okay. So guys, if you guys have observed it, I already told you that there is definitely some relation with frequency, because you can see in this, like if we have two A's, B1, there is one possibility is that we can arrange it ABA. But if we have something like this scenario, A2, A3, sorry, B1, now there is a problem. Now there is a problem. Correct? We see at a one time, okay, why this is it? So Vishal, you're asking why this is the problem? The last one? Yes, yes. So you can see if we have three A's here, you can see we can't rearrange our string in a way which requires, so everyone first understand our condition. Condition is saying two, everyone just forget everything. First understand what's the constraint here. Two adjacent letter should not same. Rearrange your string in this way, rearrange your string in this way, two adjacent letters should not be same. So you can just try to rearrange this string in any way, so your two letters should not be adjacent. But you can see here, you assign in any way, A, B, A, always A, one A will always be there, which will be adjacent to the same letter, which is A. That's why. Understood, Usha? Yeah, definitely a problem. Then we will return, whenever we see this type problem, we will simply return a blank string. So guys, for rearranging a string, at a time, we need two distinct letter. Correct? So like if I say in my heap, I'm just creating my like max heap, because I'm just creating a max heap here, A2, B comma 1. Okay. Now I'm trying to create a string. So for creating a string at a time, we need two distinct letter. Correct, guys? We need two distinct letter. Am I right or not? Yes. Once we didn't find any distinct letter, we'll say that there is some problem. We can't create it. So let's try to create a string. So first, let's pull it out. Let's pull it out. This is our max heap, which is again going to keep two things, A comma 2, B comma 1, element and frequency, like the previous question, element and frequency. So first we'll take this element out. And again, guys, we need a backup array as well. Backup array as well here as well, because we need to insert this A again back. Correct? We have to insert this again, insert this A again back. So what we'll do? A comma, yeah, just take this string for that. Yeah, first pull it out. So first pull it out. So once we pull it out and reduce the frequency also, so A comma 1, right? It will become A comma 1. And you create a final string also, because we need final string at the end. So in this final string, just add A this place. Just add A here. Correct? Just add A here. Now, before adding it back, okay, guys, can we now add it back or not? Can we add it back or not? Can we add this A back into our heap or not? No. Why? Why? Vishal is saying we can. Why, Vishal? Yes, A comma A. That's right. Suraj is saying correct. But why we can add it? See, Vishal, if your answer would be if this A is 3, see guys, everything. I am saying we can't add A this back. We can't add this A back. Why? Let me show you. Because once your A, just consider your A is 3. Once you reduces the frequency of A comma 2, right? So now if you will add this element back, so again when you will poll it, you will get the A again back. Correct? You will get this A again back, which you do not want. You want distinct letter. You want distinct letter every time. Whenever you are pulling it out anything from the mini, you want distinct letter. So that's why we will directly not add this A. So what we'll do, we'll create one more variable here. That will be called previous. And in this previous variable, we'll keep A as a frequency. In this previous variable, we'll keep our A as a frequency. Okay? And then we'll pull it out B. Let's come back to our previous example. A2 and our final string right now A and our backup array. Or I think do not need now backup array. Do not need our backup array. Rather than backup array, we'll use this previous variable, which will be keeping our two information, which will be keeping frequencies similar like that, A comma 1, because we are not going to take multiple values out of. See, earlier we have taken backup array because we were running a loop 3 times. We need a cooling period, but here we have to take only one time only. Correct? So now in previous A comma 1 is there. A comma 1 is there. Now we'll take this B again. So B and B comma 1 has come out and B frequency has become 0. B's frequency has become 0. Correct? So guys, once B's frequency becomes 0, correct, that's fine. Now what we'll do, we'll check the frequency of previous element. Whatever the previous element exists, we'll check the frequency of that, because that element will only tell us that we need to insert it back or not. This previous element frequency will only tell us that we need to add it back or not. So we'll check here the previous one, like this is the one index, right? If previous one is greater than 0, add this previous in our heap dot add this previous, and then make this as a previous. Make this B comma 0 as a previous. B comma 0. Okay guys, so we are taking one variable this time to tell us the element we need to add it into our heap or not. That element is going, that previous variable is going to help us for that. Earlier it was going to help the backup array, but this time this variable. So let me tell you again, no problem. I think somehow you guys got a little bit confusion. Let me tell you again, no problem. Let's start from the first point. So now, but we have understood, we are going to take two variables here. One is the previous. We can assign in the previous 0 comma 0. The first one. Okay, 0 comma 0. They like, or we can assign simply null also, anything, because for the first element we are not going to do anything. We are just simply assigning this element here. We are not going to do anything here. Okay, so we can just simply take it as a 0 0 0 0 here. Now what we'll do, we'll take this pole out. First we'll take the pole. So we, A comma 2 will come out. We'll reduce the frequency. Reduce the frequency. So it will become A comma 1. We'll assign this to previous. So now our previous will become A comma 1. Correct? A comma 1. We are not adding it into the heap. We are not adding it into the heap. So our heap will look like B comma 1. B comma 1. Now we'll again do the polling. Again do the polling. So it will b comma 1 will come out. Reduce the frequency b comma 0. And now we'll check the previous one. We'll check here the previous frequency is 0 or 1. If previous frequency is 1, add it back. So now we'll check here previous frequency, previous 1. If it is greater than 1, just add in our heap this, because why we are adding it, because this has one frequency, it has to go back into the heap, right? This element, the previous element which we have fetched it out, it has frequency, it has to again go into the heap. Now we can add it because b has been come out. So what we'll do here, we'll simply heap dot add our previous. Now again, now after this operation our heap will look like this, a comma 1. Correct? We'll again do the polling. A comma 1. Again reduce the frequency. A comma 0. And this time again we'll check the same condition. Previous one greater than 1. This is the previous one, which becomes 0 now. Because this previous will become b comma 0. We'll assign this, right? Previous here again. B comma 0. And now we'll not insert this one because this 0 has been, this b already has been used. So we'll not assign it back. So now our heap will be empty and we'll stop the loop here. And you can see after that our final string will look like ABA. And at the end, we'll simply check if the starting string length and the final string length, if both are same, so just return the final string as our output, else return empty string. Else return empty string. That's what, guys, we are going to do. We are going to create the final string. And how we are going to create the final string? With the help of our previous variable. Understood? With the help of our previous variable, we are just going to track that this element has to insert it back into our heap or not. And it will only happen when the previous element has a frequency greater than 0. Then we will add it back again. In the case of AAB also, if we have 3 A's, just take one more example. AAB, we have 3 A's, B comma 1. We'll again start. I'm just skipping the first step. So after first step, your previous will look like A comma 2, right? And your final string will look like A. In your final string, you've been added the A. Now your heap will look like this only, b comma 1. Correct? Now you will take out the b out. So once you will take out the b out, so b will become b comma 0. So now your previous will become b comma 0 and your final string will become a comma b. Now you will check back again. Is the previous greater than 0? Yes, it is. You will insert it back. So your heap will look like a comma 2. Again you will do the polling. And this time you will see that your previous is 0. So you will not insert anything. You will not insert this previous one. Correct? And you will not insert this one as well. You will not insert this one as well. So now your final string will become like this only, AB. The length of, you can see, the starting length is 3 and your final string length is 2. So in this scenario, we will return the empty string here. You want to see the code for that? Okay, let me show you. So this is the frequency code, guys. Like the previous one, the frequency code, the heap code. We have added all the elements which we got. So these are the same code which we have in the previous as well. So I'm just like yeah. So now you can see this is the previous array, previous pointer which we have taken. This is our final string. You can see I'm taking the peak element, adding into a result final string array P0, polling it out, reducing the frequency. I'm checking the previous one. If it is not equal to 0, just add it into the back. Add it back into the the heap and make our previous to the current polling element. And then once this loop is completed, when there will nothing be in the heap, just come out of it and check the length. The result dot length which we got after getting the final string and the original string dot length. If they both are equal, just return the result. Otherwise, return the empty string. Just check the code. Very simple, right? Earlier we were using the backup array. This time we are just taking the help of previous array. In this previous array, we are just and how this previous variable is helping us. If the previous one is not equal to 0, it means that element still has some frequencies. It has to go back into the heap. So we are adding it into the heap. Okay. Then for the previous scenario also it should be AB. No, for the previous scenario it should be ABA. For the previous scenario, you see here, for the previous scenario where we were, yeah, this A comma 1 is come, right? And for this scenario, so okay, so A comma 2 is there. Okay, so now let me see if we missed anything here. So B comma 2 is there, right? Let's do it again. You guys have seen the code also. A comma 3, B comma 1 here. Correct? So what is the first step? Take the peak element, which is A comma 3, right? This is the peak element. Then what we are doing? We are adding this A into our final string. So in final string, we'll add it as A. Correct? Then we are reducing the frequency. This is the step 2. A comma 2. Correct? After reducing the frequency, we are checking the previous array. We are checking the previous array. If the previous array is not equal to 0, add this element. Add this element. Correct? That's what the code. And then make this as a next previous. So now after this line, the step 3 would be previous is equal to A comma 2. We'll not add it here because we have taken our previous as 0 comma 0. So previous is 0. You can see the initial previous which we have taken, it's 0 comma 0. So we'll not add it here. Correct? Now let's go for the next one. Now our heap, this is the step 2. Now our heap look like this, V comma 1. A is not there. So now let's do that. Same step. Take the peak element, so V comma 1, add it into our answer string. So answer string look like A comma B, right? Reduce the frequency, which is become B comma 0. Check for the previous one. Check for previous one. So yes, it's greater than 2. So we'll add it. So our Q will look like A comma 2. And then we'll make our previous, then update our previous to B comma 0. Then update your previous to B comma 0. Okay? Update your previous to B comma 0. Okay? Now, our final string is here A comma B. Now let's go for the step 3. Take out the peak element, which is A comma 2. Do the same string, add into our answer. So A, B, A. Correct? And then reduce the frequency, which will be A comma 1. Right? Reduce the frequency, which will be A comma 1. Now let's check previous, while previous is not equal to 0. Yes, it's not. So we'll not add the previous. Correct? And then our previous will become A comma 2. So A comma 1. Right? And yes, so one thing is missing here actually. 1 minute, guys. Yes. Did you guys see that? Yes, one thing was missing here. Oh yeah, that's right. Correct? No, no, nothing is missing. That's right. So yes, so our answer looks like ABA. And now there is nothing in the heap. Now there is nothing in the heap. Correct, guys? So now we'll go out of it. We'll go out of our priority queue. And then in our answer, we'll check the starting string dot length. Is it equal to the final string length? Which is not, because starting string length is AAB, which is 4. And our final string length is 3. So we will return the empty string from here. That was the clue. Yes, then ABA will be our answer, which will not be equal to our starting string length. Then we will say that this is not the correct answer. No, no, no. A comma 1 will not go. That's what I was telling you. That's what I was telling you. A comma 1 will not go back into the heap. You can check in the code. We are not doing it. We are only pushing it when we are seeing that previous one has frequency. But in the case of B comma 0, B does not have any frequency. So we are not pushing it. Okay. Got it, guys? Joseph. Hariharan has understood. Vishal. Arad, okay. Suraj. Sir, line number 117. Sure. Line number 117. Yeah, this one. So, the same one, right? Hariharan, this one. Wherever we are assigning the previous, we are just checking the previous first index should always be greater than 0. It should not be equal to 0. If it is not equal to 0, we are adding them back into the heap. So if you just consider there is AABB, correct? So in the case of B comma 1, so if the 1 is there, we'll again add the B there. Like you can see A colon 2, B colon 2, right? If this is the case. So first time the previous would be A comma 1, correct? And we'll remove this element from there. We'll remove this element from the heap. Only B comma 2 will be there. Now the next time when we will pull it this element also. So our previous, sorry, not previous. So when we'll pull it out, so it will become B comma 1, right? So now here we are checking our previous one. If it is greater than 0, add it back. Add it back. So that's what A comma 1 will again be added. And then we'll check for A. Then we'll add the B again. That's why every time we are checking the previous element's frequency. If the previous element frequency is greater than 0, just add it back. Because we can use it again. And every time we need a distinct element. So whatever element we have used it, we'll keep it on the previous one. And we'll take the next distinct element. Then again, we'll insert the previous element back into the heap if it has more than one frequency. Understood, guys? Anyone has any doubt? I'm not seeing Joseph response. What happened, Joseph? So repeat logic, please, not getting exactly. Which, any specific line you're saying, Joseph? Any specific line? Or like which part you didn't get it? So we are using, so we see ABA. So we have a string like this. A is 2, B is 1. We need to create a string where adjacent letter should be distinct. Adjacent letter should be distinct. So like this, A, B, A. You can see all the adjacent letter are distinct, right? So now what we are doing, we are taking one variable here, previous, which will tell us whatever the element we have used while creating the final string. Like if we started with A, so we take an A. So this element, this previous variable will keep the track of it, because we can't insert it back here. If we insert it back, this will create, we can again fetch it. We can again fetch it, but we want distinct element. So that's why we are not inserting it back. So we are going to store it here. So we'll store it into the previous variable. Like this, A comma 1 with the reduced frequency. So now our heap will look like this. and in our final string we'll add A. Correct? Now we need the next distinct element, which is B here. We'll take it out. And now our heap does not have any element. Our heap is empty right now. Correct? So what we are doing, but we have one more element in our previous. So that's what we are going to the previous and checking. Do we have any element in the previous which frequency is not zero? That's what we are checking is not equal to zero. If the frequency is not zero, add it again. So we'll add it again, a comma 1. And then we'll do the same process. We'll take it out, add into our string, again check the frequency. And every time we are we are updating this previous as well. So once we have taken the b out, this a comma 1 will become b comma 0. So now we are again checking the previous element because we have again our heap is empty. Once we taken out the a, again our heap is empty. So we are again checking, is there any previous element left? We are checking the frequency. It's 0. There is nothing left. We'll not add anything in the heap. This will be our final string. And then we will compare this final string with our input. Whatever letter they have provided with whatever we have added in the heap, with that we can only create this much string. You will compare with the length, the starting string length and the final string which we have created distinct string. With this logic, we are only going to create the distinct string. And that's what we will compare the length at the end, and then we will say the answer. Yeah, good enough. Okay, guys. So how you guys feel it after completing these two nice questions? Sure, Joseph. Let me show you the code also. Code is very easy. You see, taken previous is 0, 0, just for the first scenario, result. And then you can see at the end we are updating our previous and we're checking our previous conditions as well. We are adding the previous into our heap, reducing the frequency, adding the zeroth element in the final string as well. Same steps. And at the end, we are checking the result dot length of the final string which we have created and the original string dot length. If both are equal, send the result. If not, send the empty string. So with this logic, guys, we are just creating a distinct string. Nothing else. We are just creating distinct string. Whatever they will provide, we'll create the distinct string here. Okay. So everyone got it? And still anyone has any queries? Let me know for the second question. If not, you guys can thumbs up. We will be good for the next question. No doubt. Okay. Okay. Thank you. Thank you. Let's jump into the next question now. Oh, okay. Yeah. What is time? 9:40. Okay. I'm excited for the questions. Okay, we can go for the break now, guys. So it's a 9:40. So we can come back at 9:55. Okay, let's come back at 9:55. Yeah, I didn't realize it. Now we have two questions right from the assignment. So we'll take those two questions as well. Yeah, I think last one is easy. This one is little bit thinking needed. Okay. So let's go for a break and then we'll see the next two questions as well. Just a minute. Is everyone back? I think still people are doing dinner. Anyone is back here? Just let me know you guys are able to hear me. Oh, nice. Wait for one more minute and then jump into the next question. Meanwhile, let me share my screen. Okay. So now I'm starting the questions. Let's do it 1 more minute. In previous problem, what is the scenario for A and B? It will not be the correct answer. We will return the empty string because we cannot rearrange our string in a way that all the adjacent letter will not be same. We can't arrange our string in a way. So that's why our answer would be empty string. You can see here the answer for A triple A B. Our answer is coming as empty string. Yeah. Okay. I believe everyone is back now. So now let's start our next question. Okay. Before that, you guys have any other questions? Let me know. Otherwise, we can jump into the next question. Okay. So let's jump into the next question. Yeah. Okay, guys. So you have an array and a frame of length x. You have to slide that frame on the array and find the median in each frame. Correct? So I think you guys already aware of the median code, which we have written uh, yesterday. But this time the problem is little bit like little bit twisted. They're saying we have given this array 1 comma 3 minus 1 minus 3 5 3 then 6 then 7. Correct? And then they have given one window or frame size x is equal to 3. Correct? So we have to take that frame. So let's take like this is because the frame size is odd. So you know that if the frame size is odd, so always what is the which will give which one is going to give the answer? Because in the median question in the last class we have taken two heaps, max heap and min heap, right guys? So if the frame length is odd, definitely it is going to be, which one is going to give the answer? Yes, the max heap. The p why Vishal, why min? Remember, we always divide our, like if we take this frame 131 1 comma 3 comma minus 1, first we have to sort them so they will be in order. So after order they will look like this: minus 1 comma 1 comma 3. Correct? After this you have to divide this, and always I told you you can take one extra element in max, so that's why you can see this will be your answer, max dot peak. Yes, correct. And if you are having the even scenario, then what would be your answer? Max heap plus peak of max heap plus peak of min heap divided by 2. Correct? That's what we discussed in our last class. Let me show you the code also if you guys forget. Where's the median one? Yeah, this one. You see, we have taken two min heap here. Then we are adding our number. And while adding only, what we were trying to do here, we were always adding into the max heap. And then we are checking here that, and after adding into the max heap, we are moving into the min heap. And then pulling it from the max heap, and then checking the size, like doing the balance part here. Similar thing we are going to do it today as well. Similar thing we are going to do it today as well, but just a small change will be here, which is the window. They have introduced the window into that. So let me first explain the question, then we'll jump into the answer. So you can see in the first frame, our answer would be our answer would be 1. So in our answer array, we can say it's a 1. Then this is the next frame, guys, where we need to again consider the item. So again, first we need to sort them. So after sorting, they will look like -1, -3, comma 3. Correct? So now our answer would be -3 here. Again, take this one. So -3 will be smaller. Oh, why 1 minute? I think we have written it correct. This is not wrong. This is not correct. We have not sorted it correctly. So after -3 is more smaller, -1 and then 3. So yeah, answer would be -1 here. Sorry guys for that. Yeah, answer would be -1 here. In this scenario, I think answer again would be -1. You can see here I was talking about this scenario. So here -3, -1, comma 5. So again the -1 would be our answer. Correct guys? You guys can check in meanwhile. Let's talk about this one, this frame, -3, 3, 5. So 3 would be our answer, right? Now let's talk about this frame, sorted, 3, 5, 6. So 5 should be our answer, right guys? Now let's talk about the last one, 3, 6, 7. Yeah, they are in the right format. So 6. This should be our answer. Let's check. Is it the answer we are getting here? So answer is 1, -1, -1. Okay, 1, -1, 3, 5, 6. 3, 5, 6. That's what we need to return, guys. In each frame, you need to check in. You need to go into the array, check into each frame, and make them in the order, bring them in the order, and then calculate the median for that. Then calculate the median for that. Correct, guys? I hope you guys have understood the question. Have you understood the question? Yes. With the median, just they have introduced the sliding window also. Correct? Sir, once more. Okay. So Arad, this is the array which they have given us. 1, 3, -1, -3, 5, 3, 6, 7. So always we have to take the whatever the window size they have given. So they have given window size as a 3. So take a window size of 3, order them, and then calculate the median out of it. Because why we are doing the ordering? Because we have know that we can only calculate the median when the numbers are in ordered or in the sorted manner. So that's why when we have 1, 3, -1, first we have sorted them. Then whatever the middle element was coming, we have taken it as our answer. So 1, 3, -1. If this is our array, if we'll sort them, it will look like this: -1, 1, 3. So this will be our answer for this window. Then we have brought this window. Similar we are just checking each window, sorting them, finding out the middle element, and putting it into our answer array. Okay. Understood now, Arat? Yeah. Okay. Okay, guys. So before that, let's see, our median code will work here or not. The earlier median code will work here or not. What do you guys say? Earlier median code will work here or not? I believe earlier median code should work, right? Just check. Let's check into. Let's check. Yeah, well, that's this odd scenario only. That's right. That's right. But here, guys, there is see, there is little difference. There is little difference, and that difference is in the earlier median scenario, were we were keeping all the elements when we were calculating our median. We were keeping all the elements in our heap. Correct, guys? But here we need to calculate median of only three elements every time, only of three elements. And you know that once we have calculated all these three, like 1 comma 3 comma minus 1, if we have calculated the median of this element, so after that we need to delete one of the element, because in the next sliding window first element cannot be entered. You know that, right? In the sliding window, we slide our window into the right side. And always, if you remember in the queue also, whenever we were sliding our window, we were removing the first element from our queue as well, right? Same thing we need to do here as well. We have to remove that particular element from our max or min heap, any wherever that element exists. We have to remove that element. Otherwise, it can impact our answers. Okay, guys, everyone understood why we need to remove it? Everyone understood why we need to remove element from our min heap or max heap? Okay, now you guys tell me, do we have any method? Do we have any direct method where we can remove any element directly from our heap? Do we have any element? Do we have any method? We have only two methods: add and poll. Add, we simply add the element into our heap, and poll, always remove the max element or min element. But we do not have any method like that which can remove any element from the heap. Which can remove any element from the heap. Do we have any method like that, guys? No, right? So that's what we are first going to see, that method. Yes, we will create. So first we'll see that method. Okay. So let's first understand that method only, guys. So let's create a max heap. Okay. So let's take here we have like 38. Here we have like 28. Here we can have like 29, right? Here we can have like 24. Here we can have like 25. Here we can have like 27. Okay, is it max heap? Is it fulfilling all the the properties of max heap? Yes, the parent should always be greater than the child, so it is following the max heap property. Correct, guys? Correct. Let's represent the same in array as well. Let's represent the same in array as well. So in array it will look like this. Why to take extra space? Let's just draw it here. In our array it will look like this. So this will be our root, then the first left child, right child, then the first left child, again right child, and then first left child. Correct? That will be our array representation. Agree? So now let's delete 28. Now let's delete 28, guys. Now I want to delete 28, a specific element. Remove, like I will create a method like remove, and I will pass the 28 here. Correct? So this 28 exists at this place. So first let's find out the index in our array. Let's find out the index in this array. So index would be 1. Index would be 1. Correct? Index would for that element 1. So again, same step as we do for the root, same step we are going to do here as well. Okay, so first thing, we are going to replace this 28 with 20. First, we are going to replace this 28 with 7. So this is the first step. So step 1. Step 1. 30, 27, 24, 25, and 29. Same step we were doing in the polling as well. But in the polling, we were only replacing with the 0th element, not with the we were replacing with the 0th element. But here, what we'll do, whatever index they are asking to remove, we will replace it with that element. This is the first step. Understood, everyone? The first step, everyone understood? Yes. Now we need to check the heapify properties. Now we need to check, is it maintaining the heap properties or not? So first we'll check with the parent. First we'll check with the parent, because it is the max heap. So this element, the updated element, the updated index 1, or yeah, index 1, it should be smaller than the parent. It should be smaller than the parent. So what is the, after removing, this next step is replace it with the last element. Replace it with the last element. Then check with parent. Check with parents. Means call the, which method? For checking with parents, which method we call? We have two methods, right? Top bottom and yeah, top bottom and bottom up. Bottom up. So which method we will call here? Yes, we'll call the bottom up. Yes. So check with parent means call the bottom up. And then after that, check with the childs as well. Check with the childs as well. After that, check with childs as well. So in this case, both calls will happen. So here it will be a top down. So but in this case, I think 27 is fulfilling all the condition. Correct? So 27 is our correct answer here. 27 will fulfill here. Understood, guys? These two things we are going to do that. So first we'll check with the parent, then we'll check with the childs. Okay? Anyone has any doubt here? So let's take any example. Let's think about, because we have taken example in this way. Let me just take some other example. But yeah, before that, you guys have understood. I'm going to change the example so we can understand some more things here. But yeah, but let's change the example here. Okay, I think you guys have understood. But let's change the example. So. Let's take it 20. Let's take it 20. And let's take it as in 19. Yeah, it's still fulfilling the heap properties in this array. Correct, guys? It's still fulfilling the heap properties. This will be 20. And this will be the first child would be 19. Correct? It's still fulfilling the properties. Yeah. Our new example is still fulfilling the properties. Correct. So now let's do the first step. Now let's do the first step. What was the first step? Replace the 28 with the last element, which is the 19. So 38, 19, 24, 25, and here we have 20. Correct? That's the first step. Now check with parent. Is the parent is greater? Yes, parent is greater. So no need to make any changes here. No need to make any changes here. Now let's check with the both childs. So guys, in the child scenario, you can see that it's not fulfilling our heap properties, max heap properties here. 24 and 25 both are greater. So what we need to do? We need to take max element out of it and put it into here and swap it our 19 with that. So it will look like this: 38, 25, 24, 19, and 20. Is it following the heap properties now? Yes, it is. That's what that's what guys we are going to do that. Anyone has any doubt with the second example? Are we good with the second example also? The last point repeat. Oh, okay. So see, Hariharan, what I did, first I checked with the parent. So yes, parent is not going to, parent is already greater, so no need to do any change. Now I'm checking with the childs. In the child, as I'm seeing, both childs are greater than the parent. So it is not fulfilling our maxi property. So what I did, you know that for the childs, what we do, whoever is a greater, swap it with that. So what I did, I swapped it my 19 with 25. And now it is fulfilling our, I swapped this one with the 19. And now you can see 25 is here and 19 is here. Now it is fulfilling our maxi properties. Got it? Now let's quickly see the code also. Okay, what changes I did? I just added one or two new functions there. Yeah, so let's first check our class, heap class. So swap is same. In bottom up, earlier I was not returning anything. If you see any of my other heap methods, I will show you, not a problem. You will see in bottom up, I was not returning anything. I was not returning anything. You can see this is the earlier bottom up and top bottom code. I was not returning anything. But this time we need to return. Correct? So that's why you can see I'm returning both of my current index, and if there is anything in the swapping is happening, so the swapped index, both places I'm returning. That's just one change which I did in the top bottom and bottom up. There is no other changes. You can check later also the code. I'm not doing anything, just added the return here at the end. Okay. After that, these are the older method. All the swap is everything is same. I just added two methods here, contain and remove. So I'm just checking the value which I'm going to delete, is the heap contain them or not. So that's why just simply using a array method data dot includes, and I'm just checking that value. So this is a new method contains which I added, and second one I added the remove, where I am just checking the index. And this part is if index is like if there is only one element in the in our heap, so just simply pop it out. No need to remove anything else. And if that index is equal to, and whatever index I find it out, that is the index of last element index. Just simply remove it. No need to do any those things which we are doing. If that's not the case, then you can see replace that index element with the last element in the array, and then do the pop, like remove the last element, right? And then you can see bottom up, first do the bottom up, then go for the top bottom. That's why I was returning also. So bottom up will return some index, and then for that index, go for the top bottom as well. So this one is going to check for parent, so bottom up, and this one is going to check for top bottom. Are we good here, guys? Now with the code, I will just like give you 1 minute so you guys can check here. Any questions, guys? Just write in the chat box. 107. 107. Yeah. So you can see first with for that index, we are first checking all the parent nodes. If everywhere everything is looks good, return that index wherever the conditions are fulfilling. Now check for the top bottom, means the downside for the child. Okay, the same thing, right? First for 19, we have checked for the parent. If parent is good, then okay, do just check for another child's. That's what we are doing. The line number 187 is doing the same thing. Okay. Are we good here, guys, now? With the code part also? If is Ekta dropped the class? Ekta is still there? Not seeing her response from very long back. Okay, she might have dropped the class. Okay, so are we good with the code, guys? Can we move forward? So now we know that we can simply remove our value from the heap, correct? So now let's go for the median part. Let's go for the median part. So now in the median, we just need to insert these elements in our max heap and min heap. And once the window is completing, like once the window is hitting, we just need to simply check that if the we just need to simply check that if the window is odd, if the window is odd, if the window size is odd, we just need to simply take the max element, take the peak element from the max. If window is even, we need to take from the max and min. So what we'll do, guys, so let's see, because we need to follow the order as well. So right, so let's go back to the previous page if we have that. Okay, I don't know where that page gone. Is the same page where we have the example? Oh yeah, this one. Yeah. So now let's talk about the how are we going to store our informations in our max and min heap. Correct. So as I told you, max heap is going to keep one extra element, right? Max heap is going to keep the one extra element. So what we are going to do, guys, we'll start inserting from the max. So I'm one place I'm creating max heap, second place I'm creating min heap. Correct. So the first element 1. So 1 will be going into the max heap. So it will be coming here. And in my min heap, there won't be anything. Correct. So now, now we'll go for the 3. Now we'll go for the 3. So now, guys, before into the max heap, before going into the max heap, we just need to check whatever peak element we have. What, because see, uh, uh, in the max, we need to keep the greater element, right? Let me tell you why. See, if we take the example of this one, 1 comma 3 comma minus 1, right? So after sorting, it looks like this, right? Minus 1 comma 1 comma 3. Correct? It looks like this. Minus 1 comma 1 comma 3, right? And from where we will get the answer? From where we need to get the answer? We need to get our answer from the no, middle is fine. We need to get our answer from the which heap? Min heap or max heap? We need to get from the max heap. So yes, so our max heap should look like this. 1 and then minus 1. This should be our peak element and 3 should be here. Correct? 3 should be here. Am I right or not? Our max heap should look like this. Yes? Everyone understood or not? Our max heap or min heap should look like this. Correct, guys? Yes? Okay. So that's why, guys, while inserting any element in the max, first time definitely we are going to insert the 1, but next element, before inserting any next element, we will check in the max only if the max element, whatever right now max peak is, if it is smaller, than the current element, we will not insert it. We will only insert here the smaller element. We will only insert here only the smaller element, whatever smaller element is the compared to the peak element. So see, 3 is greater, so we will not insert it here. We will insert it into the min. We'll insert into the min, and then minus 1 will come. So minus 1 is smaller than the peak, so we will keep it here. Can you guys understood what I'm trying to say here? In the max, we will, while see, we will be inserting in max with two scenarios. First, by default, we will insert. First time, we will insert in the max. First time, when we do not have anything in the max heap. When the max heap is 0, first insert to the max, because max heap will always keep one extra element. That's why always insert to the max. But second scenario is that when you will have a greater element than the peak element of the max, we will not insert it. We will only insert the smaller element into the max heap. Compared to what? Compared to the max heap peak, max heap peaks max. So you can see the condition is look like this: max heap peak should be smaller, or yeah, should be greater than the current element, should be greater than the current element. Then insert it, then add that element into the heap, into the max heap. Otherwise, else add it into the min heap. Guys, did you get it? The reason for that as well? Why we are doing it? Did you guys get the reason for that as well? Shall we do this comparison in median questions also? In median question, no, we are not doing it. We are everything adding directly there. We are adding that everything there directly, because we do not need to remove any element there. But yeah, did you guys understood here? Yeah. So now this is now you can see 3 elements has been added. Our window will be hitting. Our window will be hitting here. It means our sliding window will be hitting here. We will be checking that. So how we will check the window here? So we'll be checking with I minus uh, this will be 3 minus, yeah, and x is 3, okay, and we can say plus 1. If it is equal to 0, let's see. So value of I would be 0, 1, 2. It will be 2 minus 3 plus 1. Yes, 2 plus 1, 3. 3 minus 3 will be 2. So yeah, every time we'll check this condition, guys. If I minus x plus 1 is equal to 0, it means our window has been hit. Our window has been hit. Correct? After doing these things, min and max, we'll check this thing also. Our window has been hit or not. Correct? We need to do that, right? For fetching our answer, for fetching our median. X is the window size. X is the window size. Okay? Everyone, Arad, are you seeing it? Where we are going from here? Yeah. Okay, Joseph, you are seeing it? Where we are going from there? First, we are checking the min and max condition. Then we are checking the window. Okay, now window. So now we'll again check here. If the window size is even or odd. So if x mod 2 is equal to 0, it means even. Else odd. In the odd, just simply in odd, just simply push our answer in the result max heap dot peak. Correct? This will be pushed into a result array. And then 1 will be pushed here. Am I right, guys? The 1 will be pushed here. Right? Now we need to remove the 0th element, because this element we should not have it. So that's what we will be first checking. And how will we checking? With the same, this will give us the index. This will give us the starting position. So this will I minus x plus 1. We'll check that if data I minus x plus 1 or array, like array, we can take this as an array. This is an array, right? We are considering this as an array. So I'm just checking if array I minus x exists in the heap, just remove it. Just remove it. We need to remove it, right? We need to remove this one. We need to remove this one, right? because we no longer is going to consider it. So that's what we will be removing it, and then our max heap will look like this: -1, 3, -1, 3, because we are only going to remove it from the max heap. We're only going to remove it from the max heap because one only exists there. Correct, guys? Till now, are we good? See, question is not done. Question is not done. It's still there. The min and max is still there. Okay, because this is first condition of min. This is default condition of min and max we did. But if somehow min size is increasing, those are still conditions are there, right? We have to always balance max and min. Max should always be greater than 1, and the size of max and min we have to also consider. So let's go for next one. Okay, now let's insert the -3. Let's insert the -3. So can we insert -3 in the max or not? You guys tell me, can we insert -3 in max or not? Check the condition. Is the max heap peak is greater than the current element? It is. It is. So we can insert it. -1, 3, -1, -3. No problem. Still, you can see max and min are balanced right now. Max and min are balanced. Max can only have one greater element. So no further step needed. Again, go for the same window. Again, hit. Again, our answer is -1. You can see because -1 is the peak. Correct. Again, remove the -3 from here. Till now, are we good? Till now, are we good? We have removed the -1 as well. Correct? Correct? Okay, let's move further. Let's go for 5 now. Okay, can we insert 5 into the max? Can we insert 5 directly into the max? No, why? Why not? Because its size is greater. Its size is greater than the max heap peak size. So that's why we'll insert it into min. We'll insert into the min. Now guys, you can see that it's not balanced. Min cannot be have a greater element than the max. Correct? Min cannot have a greater element than the max. So what we need to do now? What we need to do now? You tell me. When we have this type of scenario, what we do? In the previous question we also did. Yes. Take the peak element from the min and transfer it to max. That's what we are going to do. So take the 3 from here and move it to here. And then this will look like this. Because 3 is the greater element. 3, -3, 5. 5. Correct? So we are right now talking about which window? We are talking about which window, guys, right now? Oh, 1 minute, guys. I think we have done something wrong here. See, the first index was 3. And why we deleted -1? Oh, wait, guys. We have done something wrong here. Wait. Let's go back. I think we have deleted some wrong thing here. So what was earlier? So I think 3 was here. And here I think -1, -3 was there, right? You guys also didn't notice. Right? -1, -3 is there. 3 is there. Right? No. That's not wrong. We have deleted the wrong element. Actually, we need to delete 3. See, I minus x plus 1. Once the window will go here, we need to delete 3, right? Correct? We have deleted -1. We have deleted -1. That was the wrong. So delete the -1 from here. Delete the 3 from here. This will be the current scenario, right? -1, -3, 5, 3 here. Now we'll insert the 5 here. Again, 5 will still go here. 5 will still go here. Correct? 5 will still go here because -1 is the peak here, which is still not greater. So 5 will go here. Am I right, guys? 5 will go here. So answer will be -1. That's why I was saying why -1 was not coming there. You can see that's why the answer is again -1. When I'm checking this particular window, you can see in this particular window, answer is -1. Now we'll go for this window. And before that, now remove -1. You can see now we need to remove this element. So once we remove it, it will be removed from here. Correct? Now we'll insert the 3. Now we'll insert the 3. Can we insert 3 in the max? Can we insert 3 in the max? No. We will insert into min. And this will look like this. 3 and 5. Again, max and min are not balanced. Transfer it here. Transfer the peak element to here. So this will look like this. 3 and -3. Correct? Again, window will be hit and answer will be 3. You can see answer is 3 here. Again, now delete -3. Now delete the -3. -3 will be deleted from here. 3 and 5. Now let's go for 6. Again, can't insert it here. Insert it here then. 5 and 6. Again, not balanced. Remove it. See again, same step I'm just repeating, guys. 5, 6. See, you can see 5 is our answer. Now remove 5 only. You can see we can only remove. We can remove which one? Yeah, we can remove 5. How 3? Where 3 went? Oh, sorry, yaar. I'm just doing mistakes, huh? Where 3 went? I was thinking. Yeah, 3 is here. Yeah. Correct. Now 5 is our answer. Now let's remove the 5 from here. Just stop me if you guys stuck anywhere. I'm just repeating the same step. Now 3 is here, 6 is here. Now let's go for 7. Insert again here. Again replay. Again it's not balanced. Just take it here. Just take this element from here to here. And you can see answer is 6. Now our loop will stop. And that will be our final array. Anywhere stuck, guys? Anyone? Otherwise, we can jump into the code. Okay, understood? So let's jump into the code, guys. So we have already seen these methods, remove and all these things. Let's stop it. Okay, so first thing again, creation of min heap or max heap. Already seen it in the last class as well. This is the creation of min heap and max heap. This is our answer array we are creating. We are filling all the places with the 0. We are giving a size num length minus k plus 1, which we, by the way, not required, but that's fine. If they are giving it, that's fine. It will only create these many places for answer array. These many places. These many. You see, because what is the total length here? 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 3 plus 1, which is 6. You can see the answer array length is 6. That's what they're giving, which is not required, by the way. You can simply insert it. We are not using that answer index anywhere. We're not using answer index anywhere. You can simply push it, not needed. So that's why, that's fine if they are doing it. And that J index only for answer array they are doing it. I'm not sure why they have taken it. You can see at the end they are increasing the J plus plus, and you can see using that index only into the J part. That's not required. You can simply do the answer dot push also, but they are taking it under J as well. That's fine. So like nothing to think about. It's not making any impact here. Okay. Now let's look into here, guys. So this is the first condition which I told you. Max of size is equal to 0. Always, when the max size is 0, insert it. Insert your element directly into the max. And then the second condition is if your max peak is greater than the current element, greater or equal to the current element, then add into the max. If your max dot peak is greater or equal to the current element, then insert it. Otherwise, insert into the min heap. That's what we are doing. Correct? Then Then you can see these two more conditions. So this condition is easy, right? If the min size is greater than the max size, simply take the top element from the min, pull it out and add into the max. And this condition is for those scenarios when max size becomes so greater than the min size, like, like, like this scenario, like max min. Let me tell you when this will happen. Okay, so this will happen. Let's take -1. Okay, so -1 will be here, correct? Let's take the -3. -3 will be here, correct? 2 minus 0. Yeah, in this scenario, and let's take now 4. Let's take 4. Okay, and so this 4 will go here. This 4 will go here. Correct. So let's take the answer here. So which is the smaller? -3 is smaller, and then the -1 is smaller, and then the 4 is smaller. Correct. So in this scenario, guys, when your max is becoming so greater, when your max is becoming so greater, where the difference of max and min size is greater than 1. It's still wait, guys. I think let's take one more minimum element here. Let's take one more minimum element, like -4. Okay, what should be our output here? So our output should be here -4, -3, and -1. So and then our output should be -3, right? But according to our logic, -4 will come here, and then the peak would be -1, right? We will not add anything in the mid. Anything will into the min. Correct? So this is correct. This is wrong, right? Our code will fail here. Because you can see if I'm inserting all three negative elements, my max is giving -1. That's why I just added one more condition. If max and min size, the difference between max and min size is greater than 1, then take out the max peak element from here and put it into the min. So what is happening? So see, let's insert back into this. That's what the condition is saying. You see the condition? Max size minus min size. If it is greater than 1, simply take the max peak and put it into the min element. And let me do that. Let's see. So first -1 will be inserted. Okay, we are fine. Max and min size is not greater than 1. Max and min difference is 1, right? Not greater than 1. Let's insert -3 also. -3 is there. Now you can see the max and min difference is greater than 1. Correct, guys? Max and min difference is greater than, max size is 2, min size is 0. Difference is 2, which is greater than 1. So now this time we'll take out the max element from here and put it into here, -1. And then we'll take the -4, which is again smaller than this. So we'll take it out here. And then -3 will be our answer. Understood? Understood this scenario, guys? When we have three smaller element, we need to take out some elements from the max as well. So that's why we put this condition. When the max size minus min size is greater than 1, in those scenario, take out the max peak and put it into the min. Okay. After that, it's easy. Once the window is hitting, you can see, once the window is hitting, I'm just checking that if it is even, do the max dot peak and divide by 2 min dot peak, else simply that. And then at the end, I'm checking if the max contains that number. It should not be pole, it should be removed. Sorry guys, let me correct the method name. It should be removed. Otherwise, if max doesn't contain, then it means min contains, then remove it from there. Okay, let me show you the answer also, guys. Let me see if this code is working or not. Node heap class frame dot this. You can see the final answer: 1 comma -1 comma -1 3 comma 5 comma 6. And later on you can put the console and check all other values as well. wherever you guys is stuck. Any line where you guys see that you guys is stuck, let me know in the chat. I will remove these console, or that's fine. You guys can also later check on these consoles. Okay, anyone, anywhere where you guys is stuck, any line number? If you guys have understood the logic, I think these things are easy now. Am I right, guys? Yes. What about others? Radha is saying yes. What about others? Hariharan, Vishal. Who else is in right now? Nobody is answering. Only 2 or 3 people are only answering. Parag is Sachalo answered. Okay. Yeah, Parag is also understood. What about you, Joseph? Joseph has also already answered yes. Okay, great. Just need to dry run. Yes, dry run is needed there. Okay. Let's quickly look into the last question also, guys. That question is easy actually. Yeah. Let's look into the last question, guys. So now the last question is saying, guys, that you have given a matrix of n by n and it is sorted row wise and column wise. It is totally sorted like the previous question. Correct? It is sorted row wise and column wise. You have to find the kth smallest element in the matrix. You have to find the kth smallest element in the matrix. So this time, guys, you do not need to traverse through the, you do not need to traverse through the, in any of the sorted way. You do not need to do that. Correct? You can just simply take it. And by the way, they are also saying this matrix is sorted row wise and column wise. This matrix is sorted row wise and column wise. And still, here they are not asking you to give us the merge string, merge merge final array. They are just asking you to give us the smallest number. They are asking you to give the, like, let me show you 1 minute. Let me show you. Let me write this array here. So the first array look like this: 1, 5, 9, 10, 11, 12. What is the next? 10, 11, 13. 10, 11, 13. 1 minute. 10, 11, 13. And then we have 12, 13, 15. Correct? That was the array. That was the 2D array. Where I'm going. Yeah. 159. Sorry, first was 159. Yeah. So 10, 11, 13, 12, 13, 15. And then they are giving k is equal to 8. And this was that. This is again same. Earlier we also have the same question, right? And they are saying you need to tell in this whole array, in this whole matrix, you need to tell the eighth smallest element. Eighth smallest element you need to tell here. Correct? So like in this example, if you want to see the eighth smallest element, so let's see that. The smallest they are asking or largest they are asking? Let me see. You find the kth smallest element in the matrix. Yeah, kth smallest element in the matrix. Yeah. Eighth smallest number is 13. Okay. Yes. So if we sort this array, so it will look like this. See, 1, 5, 9, 10, 11, 12, 13, and again 13, and then 15. Correct. So if they are asking about the eighth smallest element, so first 1 is the first smallest element, 5 is the second, 9 is third, fourth, fifth, sixth, 7, 8. So eighth smallest element is this 13. Got it, guys? That's what they are asking here. You have to merge all the array. We did before taking heap size k plus 1 and pole. Yes, yes. Similar to that. Yes, yes, yes. Correct, correct. We already did. Already did. Yeah, but here just the traversal part is different. Just the traversal part is different. So you just need to traverse this element one by one and create a max heap here or min heap, whatever you want to do, and then just take out, delete the, do the polling. That's what you are saying, right? Yeah, that's totally right. You just need to merge. You just need to merge, and then you need to just do the polling. And that's what is happening in the code as well. Let me show you in the code as well. Same thing is happening. You see? So we have created first the min heap here. You can see the min heap. Then we added all the elements in the min heap. Then just simply we are doing minus minus k greater than 0. All the element we are removing before minus minus k. And at the end, whatever element will be left, it will be q dot peak. That's the same question only. That will give us the answer. This is our input. Just add everything in the min heap and then do the loop. Just remove those elements till seventh index. Like in this case, till seventh index. Minus minus k means till seventh index. And then simply give us the peak result. I hope you guys have understood this. This one. This one was not difficult. This one was easy, right? We just need to insert all the element into our heap, min heap, and then run the loop. So we just need to run before one index, like seventh index. So because, if you will delete the eighth element, you will not get the answer. So that's why we deleted till seventh index, just one before index. And then we are, whatever the peak element is left, we are just simply returning the answer. Yeah, k minus 1, yes. Yeah, since it's sorted, it's become easier. Correct. We just need to traverse add all the element and just return it. Because we need, at the end we want all the elements at one place. Then start polling. That's why it become easy. In earlier question which we had, the first question which we started discussing today, in that question we have to do the polling at that time only. So that's why we have taken all the column element, then we were finding out the minimum element, then we are going traversing. Here we just need to add all the element at one place. Then we need to do, then we need to start the polling out. So that's why this one was easy. So I think, yeah, that's all from the class today, guys. Tomorrow morning, I think at 10 o'clock, we are going to solve some of the nice problems in stack. So advanced problems, I think we are going to talk about the stack problems. I think some question will be repeated there. So we'll revise them. Yes, in stack, yes. What is in stack? We'll revise them. Otherwise, we will see some new questions as well. So we'll see them tomorrow. Yes, heap completed. Heap completed, yes. Those were the questions only which we have in the heap. And those were the very nice questions. So we are now done with the heap. Now we are just going, I think all the remaining classes which is pending, those all are the revision classes which we have already done. Yes, he was interesting. It solves a lot of real life examples as well. So all the remaining classes, I think 4 to 5 classes are left. Those all are going to be revision classes in the problems. So just like all the classes are going to be the problem based, all like problem solving. Now there will not be theory now, all problem solving questions. In module, almost levels completed. Yes, all the bigger topics are completed. That's totally. We have covered tree, we have covered binary search tree, we have covered heap, we have covered queue, we have covered linked list, we have covered stack, we have covered array. Yes, these are the main data structure. We have covered the sorting algorithms, all those things. We covered hash as well. Yes. So we just now need practice required, daily lead code problem solving. Those things are required now. So we'll see some of the revision questions in our next classes, guys. And I like you guys have weekends now. I think Saturday, Sunday. So practice these problems as well, and Tomorrow we'll cover some stack problem, those problems as well. And then I think in meanwhile, they might be having some revision class again. Then we are done with this modules. Yes, we are done with the module. Actually, we are totally done. Now we have only some revised class, revision classes. We are going to solve the problem. Then we are done with this module. Totally right. I hope like at the end of this module, you guys will feel little bit confident while solving the problems. Yeah. Actually, next Friday, actually, I'm also traveling to Delhi. So I think next Friday, I'm not taking the classes. I'm not sure Anshul has already told you or not. But yeah, after like Friday, I think Saturday I will take the class because I think now 4 to 5 classes are still left on the revision. I have seen the module, so it might take next week as well. And I think at the end of November we will be complete. We will be fully done. Okay, so you will see that next Saturday class, not tomorrow's next Saturday class. I will be having some different backgrounds. Yeah. Okay, guys. So that's all from today. Let's go for sleep and then wake up early in the morning because you have to join the class tomorrow as well. Yeah. So everyone, I'm expecting everyone will join tomorrow. Yeah. So we'll meet tomorrow and talk further. Yeah. Eat, sleep, code loop. That's what the engineering life is. Eat, sleep, code loop. Sometimes actually we add travel as well in mid of that. Eat, sleep, and travel as well. Yes, yes. Yeah. Yeah. Good night. Bye bye. We'll talk soon tomorrow. Yeah. Bye bye.